Hello everyone, welcome back to Chemistry Shorts. In today's video, we'll be continuing with solving the numerical answer type questions that were asked for GATE 2021 for 2 marks. A laser Raman spectrometer operating at 532 nanometer is used to record the vibrational spectrum of Cl2 having its fundamental vibration at 560 cm inverse. The Stokes line corresponding to this vibration will be observed at dash centimeter inverse. So they have asked for the wave number corresponding to the Stokes line. So they have already given the wave number corresponding to the fundamental vibration as 560 cm inverse, and we know that the equation for the wave number corresponding to Stokes line is nu bar r, which is the wave number corresponding to the Rayleigh line, minus nu bar fundamental, which is the wave number corresponding to the fundamental vibration. So this one is already given to be 560 cm inverse. Now they have mentioned that the laser Raman spectrometer is operating at 532 nanometer. We know that a Rayleigh line means the incident and scattered radiations will have the same frequency or wave number. So that the nu bar r or the Rayleigh wave number corresponding to the Rayleigh line will be equal to 1 by 532 nanometer inverse or 10 raised to 7 by 532 centimeter inverse. Now we have all the values to be substituted here, so that the wave number corresponding to the Stokes line will be equal to 18 to 36 centimeter inverse, which is the required answer. Now moving on to the next question, the vapor pressure of toluene, whose molecular weight is 92 gram, is 0.13 atm at 25 degrees Celsius. If 6 gram of the hydrocarbon is dissolved in 92 gram of toluene, the vapor pressure drops to 0.12 atm. The molar mass of the hydrocarbon is dash. Now this is from the lowering of vapor pressure, which is a colligative property. So we know that the mole fraction of the solute Xb will be equal to P0A minus Pa by P0A, where P0A corresponds to the pressure of the pure solvent and Pa will be the partial pressure of the solution. So the mole fraction can be written as Nb by Nb plus Na, where Nb plus Na gives the total moles and Nb is the number of moles of the solute. Now they have already given the partial pressure of the pure solvent, that is toluene, as 0.13 and as of the solution, that is Pa, as 0.12. So substituting the values here, we will get 0.13 minus 0.12 divided by 0.13 will be equal to Nb by Nb plus 1. How this 1 is coming? Because Na, that is the number of moles of the solvent. Number of moles of the solvent equal to mass in gram by gram molecular mass. Here they have given for 92 gram. So 92 by the molecular weight is also 92. So 92 by 92 will give you the 1 value. Okay. So substituting that values here, we'll get, on solving this, we'll get 0.077 equal to 6 by x plus 1, where x is the molecular mass of the hydrocarbon which is to be found, because we know that the number of moles of the solute will be equal to mass in gram, that is they have mentioned about 6 grams. So 6 by the molar mass of the hydrocarbon which is to be found, let it be x. So 6 by x. So substituting these things in this equation, we will get it like this. So on solving this, we will get x is equal to 72 grams. On moving to the next question, the reaction CO plus Cl2 gives CoCl2 at 500 degrees Celsius with initial pressures of 0.7 bar of CO and 1 bar of Cl2 is allowed to reach equilibrium, and the partial pressure of CoCl2 at equilibrium is 0.15 bar. The equilibrium constant for this reaction at 500 degrees Celsius is dash. So the reaction they have given here is CO plus Cl2 giving CoCl2. Now they have given that the initial pressure of the reactants, that is CO, is having 0.7 bar and Cl2 1 bar. Now after reaching the equilibrium, the pressure for this product, that is CoCl2, is given to be 0.15. So the equilibrium pressure for the reactants can be found from this value, that is the initial pressure is given to be 0.7 and the equilibrium partial pressure of the product is 0.15. So what will be the equilibrium pressure of the reactant CO? Will be equal to 0.15. That is this is the equilibrium pressure of the product, and this is the initial pressure that was having for CO. So at equilibrium, CO will be having 0.7 minus 0.15, that is 0.55 bar, and for in the case of Cl2, what will be the case? For Cl2, the initial pressure is 1 bar. And after reaching the equilibrium, the product is having a 0.15 bar pressure. So the remaining pressure of Cl2 will be 1 minus 0.15, that is equal to 0.85 bar. Now we can find the equilibrium constant by giving the equation K is equal to P0COCl2 by P0CO into P0Cl2. So now we have all the values here. So substituting these values in this equation, we will get it to be 0.32. That is the value of equilibrium constant K equal to 0.32. So the next question is, the quantity of cobalt ore CO3ASO4 twice H2O required to obtain 1 kilogram of cobalt is dash kg. We are provided with the atomic weight of cobalt, arsenic, oxygen and hydrogen. So here what we have to find? We have to find the quantity of cobalt ore that have to be taken to get 1 kilogram of cobalt. Okay, so first let's find what is the number of moles that is present in 1 kilogram of cobalt. So the number of moles present in 1 kilogram of cobalt can be found like this, that is mass in gram by gram atomic mass, that is 1 kilogram or 1000 gram by gram atomic mass is 59. So that will give you 16.95 moles. So 16.95 moles of cobalt is present in 1 kilogram of cobalt. Now we have to see how much quantity of cobalt ore is to be taken to get 1 kilogram or 6.95 moles of cobalt. Okay. Also from this we can find that 1 mole of cobalt ore consists of 3 cobalt atoms. So the number of moles of the ore will be, again the same formula, mass in gram by gram atomic mass. Now in this question we have to find the mass in gram or the quantity of cobalt, right, to get 16.95 moles of cobalt. Alright, so the mass in gram we have to find by the total molecular mass is 473. So this will give you the number of moles of the cobalt ore. Now we have mentioned that 1 mole of cobalt ore consists of 3 cobalt atoms. So in the number of cobalt, the number of moles of cobalt will be 3 into x by 473. Okay, so now on both sides of the equation we have the number of moles of cobalt. So in order to get 16.95 moles of the cobalt, how much weight of the cobalt ore is to be taken can be found from solving this equation. So we'll get it like x is equal to 2672.45 gram, which is equal to 2.67 kilogram. So this will be the required answer for this question. Next question. The rate constants for the decomposition of a molecule in the presence of oxygen are 0.237 into 10 raised to minus 4 liter mole raised to minus 1 second raised to minus 1 at 0 degrees Celsius and 2.64 into 10 raised to minus 4 liter mole raised to minus 1 second raised to minus 1 at 25 degrees Celsius. The activation energy for this reaction is dash in terms of kilojoule mole raised to minus 1. So we know that the Arrhenius equation K is equal to A e raised to minus EA by RT, where K is the rate constant, A is the Arrhenius constant, EA is activation energy, R is the universal gas constant and T temperature. Now since we have two rate constants and corresponding to two temperatures, we can separately write it like this. ln K1 equal to ln A minus EA by RT1 and ln K2 equal to ln A minus EA by RT2. Now from equation 2 let's minus 1 and after rearranging it we'll get ln K2 by K1 equal to EA by R into 1 by T1 minus 1 by T2. Now we have all the values here, K2, K1 and T1, T2 and R values are here. So on solving this equation we'll get EA equal to 67 kilojoule per mole, which is the required answer for this question. So we have solved all the numerical answer type questions from GATE 2021. So we'll be coming with more these kind of videos. So stay tuned and subscribe for more videos. Thank you for watching.